Let us look at another example of time value of money, where we will look at different methods of finding out the future value of an ordinary annuity. Let's recall what is an ordinary annuity. An annuity is a series of equal payments made at fixed intervals for a specified number of periods. Now, if these payments occur at the end of each year, the annuity is called an ordinary annuity. So let's now take a look at the example at hand. Suppose a firm deposits rupees 5,000 at the end of each year for 4 years at 6% rate of interest. How much would this annuity accumulate at the end of the 4th year? So let us first represent this example on a time scale. So we have the total period as 4 years. So 0, 1, 2, 3, and 4. Now this firm is depositing rupees 5,000 at the end of each year. So this amount of money is going out of their pocket. So we will represent this as a negative number. Now at the end of the first year, the outgoing amount is 5,000 rupees. At the end of the second year, again 5,000 rupees. At the end of third year, again 5,000 rupees. And at the end of fourth year, again 5,000 rupees. Now the rate of interest is 6% per annum. Now we have to find out how much will the total amount be which will be received at the end of 4 years. So what is the future value at the end of the 4th year? Now each of these investments will grow at 6% compound interest per annum. So this first investment will become FV1. The second investment will become FV2. Third investment will become FV3. The fourth investment does not have any time to accumulate interest, so this will be as it is, and this will be FV4. So now this leads to our first method, which is to find out the future value using the formula for compounding or discounting. Basically, this method is easy because you do not have to remember any complicated formulas. All you need to remember is the formula for compound interest. Now, the first deposit of 5,000 rupees at the end of first year will grow at 6% compound interest till the end of the fourth year. Now the formula for compound interest, as we know from the basic understanding, is A is equal to P into 1 plus R by 100 to the power n. N is the number of compounding periods, R is the rate of interest per compounding period, P is the principal amount, and A is the amount received at the end of n periods. So here A is the amount that you're receiving at the end of the tenure. So this can also be noted as future value. P is the amount that is invested at the beginning of the tenure. So this can be noted as present value. 1 plus R by 100 can be noted as I, and this to the power n. Now for the first installment, let's say FV1, the present value or the investment amount is 5,000. 1 plus I, the rate of interest is 6%, and I is 6 divided by 100, so 0.06 n. So Let's find out how many years is this amount being invested for. So at the end of the second year, the total time frame for which this amount has been deposited for is 1 year, because it is being deposited at the end of first year. So it will gain 6% here. Then at the end of third year again 6%, and at the end of fourth year again 6%. So total time frame for which this first investment will attract the interest is 1, 2, and 3. So here n is 3. So this becomes 5,000 into 1.06 to the power 3. We'll calculate this amount later. Now similarly for the second investment, so FV2 is equal to, now again the investment amount or the present value is 5,000 rupees. So 5,000 into 1 plus 0.06, and this amount is going to be compounded for 1 and 2, so 2 years. So this is equal to 5,000 into 1.06 square. Similarly, the third investment, 5,000 into 1 plus 0.06 to the power 1, which is equal to 5,000 into 1.06. And the fourth investment, so this investment is not going to attract any compound interest because it is at the end of the fourth year. So 5,000 into 1 plus 0.06 to the power 0, which is equal to 5,000. Let us now calculate these amounts. So 1.06 cube into 5,000. So this is 5955.08. For the second year, 1.06 square into 5,000. So this is 5618. For FE3, 1.06 into 5,000. So this is 5300. And FV4 is 5,000. So let's now add these up. So total future value is equal to, so 5300 plus 5,000 plus 5618 plus 5955.08, and this is equal to 21,873.08 rupees. So this is the first method of finding out the future value, where we'll take each investment and find out what that investment will end up being at the end of the tenure, and then adding up all those future values. Now, as you can see, if this tenure is a big number like 20 years or 30 years, this method will become very tedious. So let's look at the second method. The second method is to use the formula for future value of an ordinary annuity. So as we had seen in the video for future value of an annuity, we have seen how to derive the formula for calculating or finding out the future value of an ordinary annuity. The formula that we had found out was future value is equal to the annuity amount into bracket 1 plus I to the power n minus 1 divided by I. Here A is the annuity amount, I is the interest rate, n is the number of compounding periods. So let's find out these values. So N is the total duration, which is 4. I is the rate of interest, which is 6%, or we can also write 0.06, and A is 5,000 rupees. Now let's not confuse this value of N with the value of N when we were finding out the future value for the first investment in method 1. Why are we taking N as 4 here, whereas we were taking N as 3 here? So if you recall from the fundamental video of the future value of an annuity, we found out that the future value for 4-year annuity was equal to A multiplied by 1 plus I to the power 3 plus 1 plus I to the power 2 plus 1 plus I to the power 1 plus 1 plus I to the power 0. This is nothing but the future value of the first investment. This is nothing but the future value of the second investment, and so on. Now when we were trying to generalize this with N, we had considered 1 plus I to the power N minus 1. So 3 became N minus 1 because N is 4, plus 1 plus I to the power N minus 2 plus 1 plus I to the power N minus 3 plus 1 plus I to the power N minus N, because N is 4, so N minus N becomes 0. So that's why when we are using the formula for finding out the future value of an ordinary annuity, we have to consider N as the total number of periods. So here N is 4, I is 0.06, and A is 5,000 rupees. So let's plug in these values into this formula. So 5,000 into 1 plus 0.06 to the power N, which is 4, minus 1 divided by I, which is 0.06. So this can also be written as 5,000 into bracket 1.06 to the power 4 minus 1 divided by 0.06. So let's calculate this. So 1.06 to the power 4 minus 1 divided by 0.06, and this multiplied by 5,000. So this is 21873.08 rupees. Now this is the same answer that we had gotten using method 1. Now let's move on to the third method. The third method is to use the compound value factor for an annuity, which is also known as CVFA, compound value factor of an annuity. Now the formula that we used in the previous method was future value is equal to A into bracket 1 plus I to the power N minus 1 divided by I. So here we can segregate the formula into two parts. Let's say this is the first part and this is the second part. Now this second part has two variables, N and I. I is here also. So if we find out the value of the second part, with different values of I and N, then that table will become reusable anytime we want to find the future value of an annuity. We will only need to multiply it by the annuity amount. So this second part is also known as the compound value factor of an annuity, or CVFA. We can also say that this is the future value of 1 rupee or $1 or any unit value of a currency. So let's calculate some values of CVFA just to understand how that table can be created. So CVFA, where let's say N is 1 and I is equal to 1. So this will be equal to 1 plus I is, we'll take it 0.01, 0.01 to the power n, where n is 1, minus 1 divided by I, which is 0.01. So this is 1.01 to the power 1 means it is 1.01 minus 1 divided by 0.01. So this is 0.01 divided by 0.01, which is equal to 1. CVFA, let's take when n is equal to 2 and I is equal to 0.01. So this will become 1 plus 0.01 to the power 2 minus 1 divided by 0.01. So this would be 1.01 square minus 1 divided by 0.01, and this will be equal to 2.01. Similarly, you can create a standard table with all these different combinations of n and I. So these tables have been already created and are available in any of the financial management books or even on the internet. So let's look at this table, which has already been established. So this is the table of future values of annuity factor for an ordinary annuity. We have rate of interest, that is 1%, 2%, and so on. And we have periods 1, 2, 3, 4, 5, 6, and so on. So now in our case, we have n as 4, that is this, and rate of interest is 6%. So this. Now we have to find the value at the intersection of these two values, which is this value here. So the compound value factor in our case is 4.3746. So let's use this to find out the future value. So this formula can also be written as A into CVFA. Let's plug in the values. So A is 5,000 and CVFA value we found was 4.3746. So let me pull my calculator. So 5,000 into 4.3746. So this is equal to 21873 rupees. Now let's look at the fourth method, which is to use the financial calculator. So in order to use the financial calculator for finding out the future value of an annuity, we have to consider four main buttons. First is N, which in our case is 4. Second is I, which in our case is 6. Now note that when we are entering the value of I in the financial calculator, we have to enter it as it is, that is 6. We are not entering it as 0.06. Present value, which is 0, because we are not considering the case of a lump sum investment. We are considering the case of an annuity. So in case of annuity, we are making regular payments, so we consider the button PMT, and this in our case is minus 5,000. So we are considering minus 5,000 because this is an outgoing amount from our pocket, and while using financial calculators we should enter the sign, and then we have to find out what is the future value. So let me pull my calculator. Now the method to use the financial calculator is that we'll first enter the value, and then we'll let the calculator know what that value stands for. So 4, and this is the value for n, then 6, and this is the value for I, then 0, this is the value for PV, 5,000, change the sign, and this is the value for PMT, and then we have to find the future value, so we'll simply click the FV button. So our future value comes out to be 21,873.08. So the future value is 21,873.08 rupees. Now this is a positive value. That means this amount of money is coming into our pocket. So these are the 4 methods of finding out the future value of an ordinary annuity.